Okay, hi guys, welcome to the channel. This is Waga. We are going to do another Leetcode question, and the question in question is number 10, regular expression matching, right? Pretty straightforward. Okay, it's not pretty straightforward. The number of edge cases you have to look at in this question are absolutely, it's absolutely crazy, the number of edge cases. But if you work through it, it's pretty simple, and you can solve it with recursion, right? So what we're going to do is first let's go through every test case, right? Or let's go through the instructions, right? So you're given an input string S and a pattern P. You're supposed to match S and P, and there are two wildcards. There's the period character, which can match any single character, and the star character, which can match 0 or more of the preceding element, right? So the best thing to do is to go through every example so that you can understand every single case, right? So in this case, if we have, let's come and copy this code, SA and PA. Let's pick one of this REPLs, and let's get our REPL started. And this is for another question I was doing. And so we have SA and PA. And when you try to match SA and PA, the answer is of course not, right? Because you can't match the pattern from the string, right? In this case. So in such a situation, we can just get rid of this, right? But now we go to a situation where we have AA and PA, basically that. Let's paste them. Now these two strings match because remember, as we said, the star element can match either 0 or more of this. So the star character can essentially make P be A, or it can be AA, or it can be AAA, or it can be AA. You get the point, right? It can either match 0 or more of the preceding character, right? Let me just check. It's of the preceding element, right? So the preceding character can be matched either 0 or more times by this. So these are all the possibilities, etc, right? So if you look at this situation, the pattern at P and the pattern at S can match in such a situation, right? Because of the fact that the star character can do this, right? So we can get rid of this and go to the next example. The next example is going to be this, right? So this is going to be dot star, right? So in this situation we return true because remember, the dot can stand for any character. So the possible universe of characters, if you can put all the possible characters, it could be A to Z, right? It could be A to Z, and then the star matches anything in the previous element by either 0 times, or it either matches it 0 times, or the exact number of either matches it 0 times or an infinite number of times, right? So basically you could have A to Z and A to Z, right? So from picking A to Z, you can create AB from that string, right? So from AB, from A to Z and A to Z, you can create AB. So basically that one is this should return true, right? And in another situation, this one is pretty difficult, right? So we paste this one, right? So we have AAB and C star A star B, right? So the first thing you need to know is that we could match a character 0 times, right? So in such a situation like this, we could just ignore matching the C, right? Imagine there's an I pointer here, right? There's an I pointer here, and there's a J pointer here, right? So we check and we see I and J are not alike, so we could move the J to the next one, and we could match the preceding element exactly 0 times, right? So in such a situation, let's make a possible universe of all our characters that can be matched from B to A. So we could, in this situation, ignore C. We don't have to copy C, right? So we could just have an empty string like so, right? And then when we come to A and we move I up to, I could remain there, right? A and A match, so we have an A, and then we move I to the next A, and we move J to the next element, which is going to be this, right? We move from A, and if we look at J is going to be J's the star character matches the previous element X number of times, right? or 0 number of times, as you can see from what it did to C, right? So in such a situation, we can return the previous element, which is A, and then finally we have B. If we move our I element up 1, I, and we move J up 1, J, we have AAB, right? So we have we have potentially created a match for the first element, which is AAB. You can match it using this element, right, by moving 2 pointers. So we go to description, and I've gone through the examples, and the first thing we need to do is we could create a function that will do this, right? We're just going to pass in the I and the J of the I pointer. The I pointer correlates or will work on the S pointer, on the S string, which is the input string, and the P and the J pointer will correlate to the P string, right? So, and remember what we're doing here, if I could just go over it again, we are ensuring that we can match the input string in the pattern, right? So the pattern might still have some things, as long as we match the input string. That's all that is required in the pattern, right? So we could come here and we could call it maybe I think we could call it, is it a depth first search or a breadth first search? Okay, let's just call it BFS, like so, right? And it's going to take in the I and the J, and the I corresponds to S, J corresponds to P. I think we've gone over that. And now the first thing we need to check that the I pointer and the J pointer are both valid, right? So for that we just say if I is greater than the length of S, and J is greater than the length is greater than or equal, right? It's not just greater, it could be out of bounds, greater or equal to, we could say the length and the length of the pattern, we return true, right? If both of them have crossed over, because you're going to progressively move them over each letter, right? We're going to loop through our strings, our pattern string and our input string, right? So if both of them have crossed greater than or equal to the length of S, that means that we have gone through every character, and we have similarly, it has passed all the tests, and it has also gone through every pattern character. So in this situation, what we're supposed to return is obviously true, right? Now the next situation, we check whether or not we have hit the out of bounds of the pattern string, right? If we run out of characters or elements in the pattern string and the I has not been exhausted, that means that we can't match everything in I in P, right? It follows, right? So the next thing we just do is if J is greater than or equal to the length of the pattern string, that means we have gone through S and we have not found everything we're looking for. That can only mean one thing, right? We just have to return here false, like so, right? So after that, we check if the first characters match. So we start at the very beginning, right? So we could put this in a variable because we're going to check the match for. We're going to use this a couple of times, right? And to check the match is pretty straightforward, right? We first check that I is within bounds, and we say I is less than the length of S, right? And we check that the element at I is exactly the same as the element at J, right? In this case, we have, let's say AA, right? So let's just come here and say this is going to be AA and P is maybe AA, right? So in this situation, check I is equal to P, right? So we say is exactly the same as P, J, or remember, if it's a dot, it matches any single character, right? Because a dot is from any character from A to Z, right? I'm guessing we're only using is it alphanumeric or okay, A matches anything, right? Let's just agree A matches anything, right? So if the element at J is exactly equal to the dot character, the period character, that can match any letter. So if this matches, we have a match. If we have either the characters at S at position I and the character at P at position J, or the character at P position J is a dot, right? In such a situation, we have a match, and we can continue from there. The next thing we do is we move our we check the next character. We go to the next character, and there are a few things we have to check there, right? So we know that, as you know, if a star is the first character, then it will be ineffectual, right? So a star can't be the first character because the star only works on the preceding element, right? So if a star is the first character, it's possibly useless. So we don't have to consider a star. That's why I've only considered the dot here and not the star. But now this will work quite possibly on the first element. This is what is going to run when we get to our first element, right? And these two up here are our base cases, right? When we have exhausted everything and we've gone over it, these are our base cases. Checking the length, right? So the next thing, in the next line, we have to consider the fact that we use a star, because the star will match either 0 of the preceding element or possibly an infinite number, right? So we have to consider this when we're doing when we're considering the second element, right? So how we do that is we say if j plus 1, if j plus 1 is less than the length of p, if we are still within bounds in our pattern, right? And p, and let's just spell and correctly. How am I spelling it incorrectly? And p, and the character here is a star, whatever it's called. And the character here is a star. If j plus 1, if j is within bounds, and the character at j plus 1 is the p dot star, we actually have two choices, right? We can either ignore it, right? In such a situation, like when we came here and we basically ignored c, right? We copied it 0 times, right? So in this case, you can either copy it, and you remember it says 0 or more proceeding, right? So we're going to consider both instances, where we copy it 0 times or we copy it an infinite number of times, as many as required, right? So what we do in such a situation is we either have DFS, we call DFS on I, and we move j by 1. In such a situation, if we move j plus 1 by 1, it becomes j plus 2, right? In this situation, what we're doing is we're ignoring it, right? We leave I where it is, but we move j because we're ignoring it, right? So we ignore j plus 1, right? In the case, and this worked for when we were doing the C, this, right? So we can ignore it if we want, right? So we ignore it in the pattern string, right? Or we match it, right? So we say match, and if we match, we call the depth first search on I plus 1, because we have moved I, and j, right? So basically that this line does, like I've explained, is that it checks if we're using it, if we're using the star, it has to match, and in such a situation, if it matches, we move our I to the next level, and of course we can leave our j where it is, and if we don't use it, we just move our j to the next character, right? So basically that's understood. And the next thing we need to do is we need to check match, right? So if we do have a match, if match, right, we just need to recursively return the, and we call this DFS instead of BFS, right? We should call it, I think this is a breadth first search rather than a depth first search, right? So what we do here is we return BFS, and we want to return, if we have a match, we move to the next letters and we repeat the whole process, right? So it's I plus 1, j plus 1, so we move it up 1 level, and if we move it up 1 level, what we're supposed to do is we're supposed to come here and we say return false, like so, and afterwards what we're supposed to do is we are supposed to return DFS and BFS rather, BFS, and what we call it on S and P, and we call it at position 0 on each, right? So we call 0 and 0, like so, right? So basically that. So this is we could call this our naive solution. We need to make sure that we check that j is equal to the length of p, right? And that we return, after we check our wildcard, we need to return whether this is evaluated to true, And finally, we need to make sure that this if blocks match, right? This and if match. So just correct your code like that, and when you run your code, it's hopefully going to be accepted, and if we submit it, it's also hopefully going to be accepted. So basically that is our code. Our time complexity is going to be O of n. Our space complexity is going to be, we don't create any structures, right? So we're just going to have an O of 1 space complexity, right? If I'm not wrong, we do not create any structures. Yeah. So this is going to have a time complexity of O of n and a space complexity of O of 1, right? You could also use caching, but I'm not going to go into that. But you could use caching to make our code move a bit faster, but the space complexity, calculating it, is going to be exactly the same, right? It's going to be maybe a significant increase in our speed, but it's not going to change it into, it's not going to make it better than O of n, the time complexity. Thank you for watching, subscribe to the channel, and I'll see you in the next video.